So in this video we will discuss about why NAND gate and NOR gate are called universal gates, or I will show you the proof of universality of NAND and NOR gate. So let's begin. So we all know that NAND and NOR gates are called universal gates. So what do you mean by universal gates? It is nothing but by using universal gates you can represent or construct any basic gates like OR gate and AND gate or NOT gate. By using these NAND and NOR gate, you can prove or construct OR gate, AND gate and NOT gate. So let's prove them and construct them. So let's begin with the proof of NAND as NOT gate and NOR gate as NOT gate. So just here I have drawn a simple NAND gate with one single input A, and we all know that NAND gate is the inverted version of AND gate, which is the combination of NOT gate and AND gate. So it will be inverted here, and we give an input of A and we will get an output of A bar, which is the inverted version of A. So if you give input 0, you will get 1. If you give input 1, you will get an 0, like the NOT gate. So this is the basic construction of NAND gate as NOT gate. Now let's see the NOR gate as NOT gate. So it will be the same like NAND gate, where A will be our input. Just draw a simple NOR gate and our output will be A bar. So this is how you can prove NAND gate as NOT gate, NOR gate as NOT gate. Now let's see the another one, OR gate. Now we will see NAND gate as OR gate and NOR gate as OR gate. For NAND as OR, we have to take two different NAND gate of two different inputs. So draw a NAND gate of input A, draw a NAND gate of input B, and here you will get A bar as output and B bar as output. Now just combine them together by another NAND gate, and you will get an output like this and a whole. But this is not how we represent OR gate. For that we have to simplify them. So just simplify them like this. Here you have to break the bars and cancel them out. But how can we do that? And how can we get an OR symbol? Because here it is an AND symbol here. But we need to prove NAND as NOR, OR. For that we have to implement here the Boolean laws. If you apply Boolean laws here, you will get like A or B. The bar will be separated and two bars can cancel each other, and you will get an output like A or B, which is the proof of NAND as OR. Now let's see the NOR as OR. You just need a NOR gate of two inputs A and B, a NOR gate of two inputs A and B, and here it will look like A or B whole bar. But here we have to implement another NOR gate. For that our output will be like A or B 2 bars, and these will cancel each other. We will get an output like this, which is the proof of NOR as OR. So let's see the NAND as AND gate and NOR as AND gate. So for that you have to take two inputs A and B of a NAND gate, and it will look like A and B whole bar. So here we can just put another NAND gate and we will get an output like whole bar. These will cancel out, and simple, we got the output of AND gate. So this is the proof of NAND as AND, and now we will see the NOR as AND. For NOR as AND, we just have to take two different NOR gates of two different inputs like A and B. Here it will contain one NOR gate, B with another NOR gate, give us output like A bar, B bar, combine them together with another NOR gate and it will give us the output like A bar plus or B bar whole bar. So just apply Boolean law here, which will look like, just apply Boolean law here and you will get A and B bar and two bars will cancel each out. So we will get A and B, which is the proof of NOR as AND. This is how we can prove the universality of NAND and NOR gate by constructing or representing the basic gates with them. So you just have to remember them. Thank you for watching this video.